This is the in-class assignment looking at using the first derivative test to calculate the extrema. And I'm going to pause for just a second. So there are two problems. I think they're both polynomials, maybe. No, the second one is, yeah, they're both polynomials. So it says find the intervals of increasing and decreasing functions for the function f of x equals negative x cubed plus 7x squared minus 7x minus 15. So this is a cubic. It's going to have a, just from past experience, we know it's going to look something like this. So it starts at positive infinity, goes to negative infinity, does something interesting in between. So the first thing we're going to do is find the critical numbers by taking the derivative. So we get negative 3x squared plus 14x minus 7. And we set that equal to 0. So let's just divide by negative 1. I mean, the original function is negative, but to find the zeros, it doesn't matter whether we multiply by negative 1, so we can do that. So you'll end up with 3x squared minus 14x plus 7 equals 0. And this could be factored possibly, but it turns out you could need to use the quadratic formula, where a is 3, b is negative 14, and c is equal to positive 7. And the quadratic formula says that the factors of that equation, or the zeros I should say, are negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So for our particular case, we have negative 14 plus or minus square root of negative 14 squared minus 4 times a, which is 3, and c, which is 7, all divided by 2 times a. So we'll get 14, negative times negative is positive, plus or minus the square root of something, which is going to be 14 squared minus 4 times 3 times 7, which is 112, all divided by 6. And if we do both the plus and minus square roots, we'll get 4 plus the square root of 112, all divided by 6. Is 4.1. So that's one solution, and the other solution is the negative square root. And I get 0.57. Just double checking, make sure everything looks okay. Okay, I hope that's right. If it doesn't, we'll re-record it. So those are my two values of x where the first derivative is equal to 0. So now what we're going to do is we're going to create this table, and it's going to be 4 by 4. 4 by 4, yeah, that's right. So for these first derivative test problems, we always have 2 extra columns than the number of critical numbers. And then we fill it out with the interval, an x inside the interval, the sign of the first derivative, and a comment. So our interval goes from negative infinity to 0.57. I'm just going to put 0.6. From 0.6 to 4.1, 4.1 to positive infinity. Now we're going to pick some values of x which are in each of these intervals. So 0 is a good number, 1 is a good number, and 5. So 0 is less than 0.6. Then we go back to the equation for the first derivative, and we have to make sure we don't use the simplified version where we divide it by -1 or we'll get the wrong answer. So we're going to do f of 0 or f prime of 0, so that's -7, which is negative. So put that in there. We do f prime of 1, which is -3 times 1 squared plus 14 times 1 minus 7. And so we'll get -7 minus 3 is -10, plus 14 is +4. So that's positive. And then finally, f prime of 5 is -3 times 5 squared plus 14 times 5 minus 7. So that's 25 times -3, which is -75, plus 5 times 14, which is 70, minus 7. So we get -82 plus 70, so that's -12. So that's negative. So that's negative, comment, decreasing, increasing, decreasing. So so that is the that's the information about the increasing, decreasing nature. So here we go from decreasing to increasing, increasing to decreasing. So that means we have a minimum here and we have a maximum there. So we can write according to the first derivative test, so according to the first derivative test, we have a local minimum at x equals 0.57 and a local maximum at x equals 4.1. Now in the problem they ask you to find the intercepts of the original function. So let's write the original function. So we get f of x equals -x cubed plus 7x squared minus 7x minus 15. So the questions are, what are the real roots? Well, if we use pre-calculus, we'd say they're plus or minus 1, plus or minus, could be possible ones, plus or minus 3, plus or minus 5, plus or minus 15. So we have 8 different choices. But let's do one extra thing here. Let's evaluate the function at the 2 critical numbers. So here's the function. Let's evaluate the function at 0.6. So we get negative 0.6 cubed plus 7 times 0.6 squared minus 7 times 0.6 minus 15. So go ahead and stick that in your calculator. So I get negative 16.9. And the function at 4.1. And I get 5.0. So that's the function of 4.1. So now let's use that information to plot those 2 points on a graph paper. Okay, so 4, 1, 2, 3, 4. And let's make the function, let's look at the scale here. So we've got negative 16. So let's do negative 20. So this goes down to negative 20. This goes positive 20, and we'll go from negative 10 to positive 10 on this axis. So we get 4.1, so that's 1, 2, 3, 4, 4.1 and 5. So that's 2, 4, 5, be about right there. So that's that point. And then we had 0.6 and negative 17. 0.6 and negative 17, which would be, there's negative 16, negative 17. So that'd be about right there. So what we're going to have is we're going to have a minimum through here. We're going to have this thing go up like that. And it's going to loop around and it probably does that a little faster. Like that, and it'll go back up and it'll like that. So it looks like there's going to be one around positive 3, maybe positive 5, and negative 5. That was just based on this rough sketch and because of the possible roots that we had. So let's try any of those. So what we think is negative 5, 3, and positive 5. So we take our original equation, which was negative x squared plus 7x minus 7 minus 15. And these are the zeros, so we can just put those in. Let's do 3. So 3, bring the negative 1 down. Negative 3 times negative 1 is negative 3. 7 plus negative 3 is 4. Then you have 4 times 3 is 12. Add those together, you get 5. 3 times 5 is 15. You get 0. So what we're left with is we have the factor x minus 3 times the resulting negative x squared plus 4x plus 5 equals 0. And if we factored out a negative sign, we get x squared minus 4x minus 5 equals 0. And at this point, we can factor this. So we would get, we got negative 5, so we got to have a 5 and a 1. And because this is negative 4, we're going to put the negative in front of the bigger term and that. And so I didn't get exactly, I did this last time. I did this problem. That throws me off. It was positive 0.6 and negative 6, negative 17. So it's actually right here, about right there instead. So it's going to go up. It's going to go like that. This one's going to loop around. It goes back up pretty fast. So that was because I drew that thing wrong again. So this looks a little more like negative. And this should be positive right there. So positive 1, negative 1. Yeah, okay, it's negative 1. And you can see what we get is the solutions to this thing of factoring the original function. We get x equals 3 as a solution. We get x equals 5 as a solution. We get x equals negative 1, which is a solution. And we're done. So let's go ahead and do the graphing program just to show you this is true. So let's get my camera. So we're going to put in the function, which is negative x cubed plus 7x squared minus 7x minus 15. And I graph it, and then I zoom out in this direction. And there you go. So you can see we have a maximum at 4.1, a minimum at 0.6. We have an x-intercept of negative 1, 3, and 5. And so everything's good. And let's just copy that, put it in our little thing. So we're going to take that over here. We're going to stretch it out a little bit. So that's it. We're done with that one.